everybody's jumping on in here. All right, look at us. Love it. Good morning, good afternoon. I'm having some coffee. This is super duper good stuff here, guys. I can't wait to get rolling for today. I thought
good afternoon.
That early.
Good afternoon from Norway.
Oh, good afternoon, Norway. Good to see you. Good to see you. Jan, that's Jan. Okay.
Yes, hello.
This is why I want to do this, is I get to see people's faces. They get to talk. It's just not me up here going like this. So this is good stuff.
This I'm learning from you.
Beautiful. Beautiful. I think I liked that just a minute ago on Facebook. Yes. Wonderful. I'm going to kill my...
Thank you very much.
Oh, thank you. I appreciate all the support you guys give me. This is wonderful. I think this Zoom is going to be so much better than this Facebook and OBS software and blah, 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 all kinds of problems. We don't have that anymore. Enter full screen. I might as well go full screen. There we go. Wow, that looks good. I love it. And I think we'll get some more folks in here.
Can I talk a little? If when you are talking, then everybody mute their microphone because there can be some resonance. I learned that from my students earlier this week.
Good point. Very good point. I have this. I went ahead and got the pro edition of this Zoom, so I can set when people come in. Hey, good morning, Tim. When people come in to the room and to the meeting, they're muted automatically, and then they can unmute themselves if they want to talk. That's a good point, though. Yes, we'll get a few people in here and get rolling on here. That's great. I love it. I love it. Isn't this so much better? I mean, this is just so much better. But we're still a little early. We've got people coming in. I am recording this. And so I may put it up on YouTube, or I may just say, hey, you got to come into the Zoom show. And, but I think it's good for posterity's sake. We'll see. And guess what? I can share my screen now. I don't have to, let me try that. Let's see. I'm going to try something here. I wanted to jump in here and see if I could do this. And let me see if I can. Let's show a little piece on here. If I open that up and I say share screen, preview unknown. Okay. Yes, I do too. I think it's wonderful. So much better. So much better. Unlock. I guess I have to make sure I can share this stuff, huh? So preview, reminders, where's preview at? Photos, camera, maybe I just do my desktop. Share screen, desktop, open system preference, security, and privacy. Let me see if I can do that. Privacy, well, I got everything checked here. I don't know why. I want to be able to share my desktop here. Camera, photos, location, general. Just trying to look how I share my desktop real quick, guys. Google Chrome. OBS, Sonos, Photoshop, fold this. Yeah, let's do that. Desktop folder, this should all be shared. I should be good to go here. See if I can do this. All right. Well, we're getting close to this time. We're going to start up here, guys. And those that want to join us can. There's a chat. That's awesome. Yeah. I'll post on YouTube. That's good. I like that as well too. Let me see if I can do this. Your computer, desktop. I'm trying some things because I've never got to do this, right? So here's a little screenshot from redeveloped and not redeveloped. So we love it. This is so good. I'm doing a little bit different lighting. I'm trying my CFL bulbs today. I think the balance is better. There's no glare. And we know we're going to redo last week because I had so many technical difficulties. It was so frustrating for me. It was really, really kind of a bad deal for me that way. But we're not going to fret over that. Today, I'm going to talk about development, redevelopment, answer some questions that we've had. Man, I got some radical different, I don't know if, I think I showed these last time, but I've been printing out since everybody's kind of quarantined now, right? At least we're trying to be anyway. I got some radically different, I think my colors show better here too. I get some radically different, can I do speaker view? Spotlight, yeah. So if I did that, yeah, those are, wow, look at the color. Those are real colors. That's the first time I've seen real colors come through. Getting radically different printing out colors, which is just absolutely awesome. But today, let's do this. Today we're going to talk about developing, redeveloping, how development works, redeveloping, and answer some questions. So let me open this up, and I'm going to go first to, I have to have notes because I'm so, I don't know, I can't remember everything. So I have to have my little notes pulled up here. So today is the 21st of March. It's, what is it? It's 5 to 10 a.m. It's 9:56 a.m. in Mountain Standard Time here in the Rocky Mountains. Beautiful sunny day today, cold. Tim knows this. We got pounded with snow yesterday, day before. I think, if I'm not mistaken, I think we had almost 10 inches, 25 centimeters of snow yesterday. So my neighbor let me borrow his snow blower, made quick work of the driveway. Still got a little bit of shoveling in. I hope everyone's doing well. I think with all this Corona stuff going around and everybody's concerned with isolating themselves and staying away from people and all that stuff. We've heard so much of that. It's great to come in and talk about something else other than the virus. Although we know we have to talk a little bit about it and wish everybody well. We don't want anybody sick. Fortunately, right now, I don't know anybody that's sick from it. I don't know. Jeannie and I, my wife and I, we're here all the time anyway, so it's not that big of a difference for me or us, this lifestyle. We're pretty isolated anyway. Like I said, I'm saving up and have been for many years to head up to the mountain. And so every penny we get, we don't go to the movies, we don't go to concerts, we just don't do any of that stuff. So it's not a big deal for us, but I wish everybody well, and I hope everybody's safe and sound and feeling good. So moving on to a brighter and better topic, we're going to be working out of, I want to talk just a little bit out of the book. If you have the book, if you don't, that's fine too, because we're going to be able to get you through it anyway. I just want to talk a little bit about redevelopment, development and redevelopment. So there's two different areas here. Chapter 11 is making negatives. And if you look in on page, we're going to start with page 135 and we'll move into 136. I'm just going to review those. So let's talk about development first. What we have when we talk about development, when we talk about exposing a plate that's been sensitized, and we know this, we'll go over it again though. When we talk about exposing a plate that's been sensitized with silver nitrate, with a layer of our good old collodion, right? Our salted collodion, meaning we have plain USP collodion. We add a little bit of alcohol. We add a little bit of ether additional to it. And we put one or two salts or three salts, how many ever we want in there. And we make it available for this double replacement process. And I think, and I'll just pull this up so you can see it. I should actually, you know, when I get better at this, I'll be able to just pull up, I'll just be able to pull this up on the screen and show you guys this. But this is what we're going to talk about. We have to start here with double replacement. And remember those two salts converting over as you put it in the silver bath, those two salts talk to the AgNO3 or the silver nitrate, and they say, hey, let's exchange ions, cations and ions, and they form what we call silver iodide and silver bromide, the two light-sensitive halogens. We talked a little bit before about calling this an emulsion or calling it a suspension or whatever we want to do. I know technically it's not correct to call it emulsion, but I call it emulsion because it's a light-sensitive material, and it's easier to convey to people without damaging verbiage or anything else to call it a light-sensitive material or an emulsion. So when we talk about emulsions, what we're talking about is spinning silver nitrate, like a colloidal chloride emulsion. That's where you take the collodion and the salt, glycerin, the citric acid, and you spray the silver nitrate into the emulsion, into the mix. That's an emulsion. When we talk about emulsifying something, we usually talk about spinning that product in. So although this is technically not an emulsion, we'll call it an emulsion for now, or film. We can call it film if we want. Anyway, those two exchanges happen. We have byproducts from that. We talked about the nitrate byproducts, how to get rid of those in heavy maintenance. Then, now we move to exposure. We expose that plate. The light energy that hits that plate starts the reduction of that silver iodide, mainly silver iodide, and silver bromide. What happens when we pour the iron? What do we have in the developer? We have iron. We have the carrier, the DH2O or the water. We have the iron, the ferrous sulfate, which is the reducer. We have the acid, glacial acetic acid normally, which is the restrainer. And we have the alcohol, or a little bit of alcohol, which I call, I say flow or viscosity. I think I'll start calling it a lubricant. And I know that's incorrect too, but why would I call it a lubricant? Because the alcohol helps the developer, really the iron and the acid, flow over the plate evenly without starting and stopping. When we start and stop with that, we get developer sweeps, or we get the islands. You know, it goes around, it doesn't cover the plate. So you have big open void areas that aren't developed. So the alcohol, minimal you can use, get away with, experiment. You'll build a little more density. You'll have fewer problems in the development stage if you, the least amount of alcohol you can use. I've said this many times, if you have a brand new silver bath, you have brand new silver bath, you need no alcohol in your developer until you start seeing sweeps or problems with that. Then you'll have to add a little alcohol to your developer. But brand new silver baths that aren't stuffed up with ether and alcohol, remember we smell our silver baths, and if we smell those solvents, we know we need to aerate and do those things. So back to development. So you pour that developer on water, iron, acid, and alcohol. And that iron, once it hits those highlights, or where that light energy is hit, that, remember the entire plate is covered with silver, free silver. And this is important to decompose that to the pure metallic state. You have to have that covered, and it has to be wet. That's why when the plates start drying out, they're not sensitive, because that free silver is gone in the state that it needs to decompose or create metallic silver. So when you pour that developer over the plate, what you're looking at is a reduction. That's why they call it a reducer. Just like putting sugar in a pan or onions, you reduce those things on the stove, right? With heat. The reduction reduces those silver iodides and silver bromides to the pure metallic state of silver. That's what creates your highlights, your midtones, and then down to your shadow areas or your void areas, you shouldn't have any reduction because there's no light energy hitting there. But what happens sometimes in the summertime, or if you don't have enough restrainer in your developer, you will develop that unexposed silver. We call that veiling. Sometimes in the 19th century, I've seen it called scumming, those kinds of things. You know the difference between veiling and scumming or fog by taking a cotton ball when it's wet and roll a cotton ball, wipe a cotton ball over that void area. If you can wipe that developed silver off of there, right, developed material off of there, and you see that nice black void area, you know that you need to add more restrainer to it or shorten your development or lower your temperature. Those are basically the things that will create that to decompose or develop that unexposed silver out, those three components. When you take that cotton, it looks like you have veiling on a plate. You take that cotton ball and you roll it over that and it does not wipe off. That tells you there's a problem either with your silver bath, your alcohol, it's too basic, you have a pH that's too high, you need to take that pH down, or more than likely, you have a light leak somewhere in your plate holder, in your dark box, in your dark room, in your bellows, in your camera. Light leak is usually, you can usually tell a light leak. A lot of times if it's in your bellows, it will be more pronounced in one area. It might be a streak. And I've had these old Petzval lenses. They'll come in, big glass with no coating. That light comes in every angle. That's why they have such a big flange on them, right? A lot of times I'll have to shield that, especially if I'm outdoors. I'll have to shield that wherever the sun's coming in because, man, you'll get streaks and all kinds of variations on that. So a fogging issue is usually a light leak. Sometimes your silver bath being too basic. But look for those. If it doesn't wipe off, it's a light leak or a silver bath problem. If it wipes off, it's a developer problem, meaning that you don't have enough restrainer, it's too warm, or you've pushed the development too far. Why we say 15 seconds? Why do we say that in development? Because you need a baseline. You need some standard that says, I don't know what this exposure is. I'm going to start at 5 seconds. I'll bring the plate in and I'll develop it for 15 seconds with all things being equal. Your collodion, your silver bath, and your developer at the right temperature, all those things. And you know that in 3, 4, 5 seconds usually, depending on the temperature, it'll vary a little bit. You'll know if you start seeing highlights that your exposure was probably pretty spot on. If you pour that developer on and you see that whole plate flash up and everything comes up, your exposure is way over. If you pour that developer on and you wait 8, 9, 10 seconds, you start seeing highlights, you know you're underexposed. And that's what tends to happen to people. They underexpose, they pour the developer on, they wait and they wait and they start seeing something come in and they keep going. And guess what? There's not enough restrainer in there. The whole plate's covered with silver, iodides, bromides, halogens. They put that, they leave that developer sitting on there and they develop all the unexposed silver as well. That's why you get that veiling. Usually you can wipe that off. It's nasty. Technically, you should never have to mess with the plate after you develop it. You should not. Now, for those of you that have been in my dark room and you've seen my operation, here's my theory. Now, you guys are welcome to disagree with me here, but here's my theory. I've been in this process almost 20 years now, and I still cannot control the exact temperature, the exact humidity, the exact exposure, the exact time, all those things down to a science. I can't do that. So even if I develop a plate and everything's technically correct, I still look at that plate. There's no veiling, there's no unexposed silver developed that I can see. A lot of times I'll still take a cotton ball and wipe that off, just one time lightly. Why is that? Because I found at the end of the day that you'll still have tiny, tiny particles, tiny, tiny pieces, small silver that's developed out on that plate that you can't even see with your eye. You dry the plate, you wash the plate, you dry the plate, you put it over your stove or lamp or whatever you're going to do to varnish it, and you go to varnish it and you get a bunch of pits. And people write me all the time, I filtered this varnish 1,000,000 times. I've done everything proper. I think a lot of times it's a tiny bit of silver, unexposed silver that you can't even see with your eye that's coming up. And boy, we know it doesn't take much for that varnish to show a little fisheye, to show a little piece of this or that. It doesn't take much at all. So that's my theory. Try it and see if you see any difference. I think you'll find a big difference in the quality of the varnish job. And I know it's a lot of times the varnish is an environmental thing. It's alcohol content in the old collodion. We'll do a varnish segment. I'll get into the chemistry on varnish and the techniques there on a different session. So development is really, that's the crux of this whole thing, right? If you don't have your exposure and your development down, it doesn't matter how good your composition or how good your chemistry is. If it's technique or chemistry failing on you in that specific moment, especially for negatives, you're just not going to do very well with it. So we reduce that exposed silver down to the metallic steady silver, gives our highlights, our midtones, and our void areas, or where there's shadow, or should be nothing. If you're on clear glass, it should be clear glass. If you're on a tin type or lumitype, it should be black, or whatever substrate you're using. You should be able to clearly see through that. And one thing I'll say about ambrotypes and negatives, if you can put your finger behind the glass where the void area is and see directly through it like there's nothing there, and the rest of the image looks good against black or with transmitted light, however you want it, negative or positive, you have done a good job with exposure, and you've done a good job with development. That 15 seconds is crucial to hold, because like I said, it gives us a baseline so we can either step back decrease our exposure or increase our exposure. You never want to change your development time. Adjust your chemistry. I start out with this. I say adjust your exposure first, your chemistry second, and your technique third. You should never adjust that 15 seconds. If you go 12 or 13 seconds on one side, or 17 or 18 seconds on the other side, that's getting in there, right? If you're a little underexposed, you have to go a couple of seconds extra. That's when you really want to take that cotton ball and make sure, even if you don't see any veiling on there, you really want to take that cotton ball. If you're a little hot, if you've overexposed the plate a little bit and you underdevelop, you're not going to get those tones like we talked about. You're not going to get those rich tones. You're not. The beautiful thing about ambrotypes and tintypes are that those beautiful midtones, right? Those gorgeous tones that we get in this process. That's why a lot of us love this. Is it rivals film? It definitely rivals digital. There's that beautiful je ne sais quoi, right? There's something there, right? There's a beautiful kind of look and feel to these things. And if you don't nail that exposure and that development, you'll never see that. I tell you this every time I'm on here. Every time, I've been getting a lot of Facebook time lately, but I don't really spend a lot of time on Facebook or social media, so I don't see a lot of the images. But the ones that I have seen lately, they're all overexposed. All of them are overexposed. And that tells me that maybe they're a commercial kind of product and people tend to like the brighter images, in the commercial aspect. If somebody comes, hey, I want a portrait done. But really, what we're talking about in wet collodion are those tones in that big range of beautiful, subtle, you talk about a scale 0 to 10, right? You get every gradation and every beautiful, and then if the color's right and everything is just beautiful, there's nothing that can beat a beautiful wet collodion image. So it's really important you get the exposure right and you get the development right. So that 15 seconds, hold to that. If you have problems, if you're going longer, it means you need to increase your exposure. If you pour it on and it pops up, you need to decrease your exposure. Find that beautiful center point. So you're at about 15 seconds when those shadows start appearing, and you arrest development. Now, how do we arrest development in wet collodion? We don't use acid stop bath like in traditional develop out film or develop out printing. We use water. And fortunately, we can use just regular old tap water, right? We wash that away so quickly. We've already reduced everything. So we're metallic silver now. We're not really exposing, no pun intended, exposing ourselves to some interaction with heavy mineral water or something like that with the tap water. So we use tap water. And basically what we're doing is we're just washing the iron off that plate. Now, what you're going to see, those rivulets when you're sensitizing the plate before development, those rivulets, a stream of water or a stream, right? Those rivulets on the plate. Somebody called them legs last time, which it's a good word for it. We struggle with the vernacular in this process. So, but when you see those rivulets on the plate, when you're sensitizing your plate, that's due to the alcohol. When those go away, it means your iodide and that double replacement has taken place fully. And you can do it. You can lift it up about after 30 seconds and just start plunging it back and forth. And within a couple of minutes, you're fully sensitized. That process has taken place. So when you pour the developer on, that iron can hit it. The reducer hits it. The iron, the restrainer goes into effect, meaning the acid holds back that development, just like in film, holds back that development so you can get all your highlights, all your midtones, and leave your shadows alone. So it's really critical to understand the balance of restrainer and developer as well too. In the hot weather, you're going to need more restrainer. Making negatives, you're going to need a lot more restrainer, right? We talked last week or the week before about, maybe last week I did, so maybe I better rehash this. We talked about the percentages of iron and acid, or reducer and restrainer in positive versus negatives. Negatives require a lot more because what you're trying to do is you're trying to bring out those subtle, I mean, I have negatives that when you print them, you don't even see the information on the negative. You hold it up to the light, you don't even see the information. You print it out and it's there. Those are the kinds of things negatives can produce. Positives, we use underexposed negative, put it against something black, and use reflected light off of it. You're going to get a lot of information, just like I said a minute ago, but you're not going to get that kind of negative information that you'll have in a negative, rather, or let's say in a print, right? So that's why it's really, really important to work clean when you're working with negatives, because it shows everything. So with positives, we're trying to make a very underexposed negative, put it on black, and we're going to get all those midtones and everything visible to the eye, but we want to do it quickly. So we use less restrainer and more acid, or less reducer, less iron, or less acid restrainer and more iron. In negatives, we do the opposite. We use a lot more restrainer or acid, and we use a lot less reducer or iron. And that's to give us a minute and a half, whatever, to pull out all the information in the negative, all of it, without what? Without veiling or fogging the image. Because once you do that, the negatives are over. Negatives get a little tricky. So that percentage is about half the reducer, half the iron in negatives, and about twice or even sometimes more acid or restrainer in the negatives. So positives, think of positives as are quick visual information as reflected on black, and think of negatives or deep information, transmitted light going onto a print. And that's why those differences are so extreme. And people ask me all the time, can I make negatives with positive chemistry? Yeah, you can. What you're going to find is that you're not going to be able to develop long enough to pull out all the information in that scene, which you could do if you had more restrainer and less iron in your developer. And even going back to your collodion mix is a little different. You're not going to get the higher iodide, so you're not going to take on as much silver and go to your silver bath. Your pH is a little more alkaline or basic. You're going to take on more. You're going to have more of that double replacement happen, which puts a thicker or more silver onto the plate. Those are all the things you want for making images. Let's see. Sorry, I didn't even look at the chat here. When I started doing my plate, it improved a lot. Oh, good. That's good to hear, Peter. Do you ever hear about slightly salted water stopping development quicker? You know what, Craig? You're absolutely right. Why is that? Do you know why that is? Let's unmute you here. Craig, you're there, buddy, right? Oh, are you muted? Let's unmute you. Sorry. Go for it. You there?
Yeah.
Okay. Do you know why? What about a little bit of salt in the stopping development? Why is that, do you think?
Actually, I don't know.
Okay, that's great. That's fine. That's why you're here. Perfect.
Hearing about it quite a while ago.
Yeah.
Yeah.
Perfect. And I'll tell you why that is. Let's jump over to colloidal chloride prints for just a second. After you make a print, you expose it, you take it out of your contact printer. Remember, we put it in the water, and I talk about that free silver coming off the print like that. That comes off the print because my water here, it won't be that way on the mountain because I'm on a well, but my water here has chloramines in it, chlorine and chloramines. There's a combination. I can't remember the other compound or chemical, but that chlorine is what happens is it binds with the silver and precipitates that out. And it's oblivious to water. It's impervious to water. So when you put slightly salted water into arrest development, what you're doing is you're pulling all that right off. You're combining that action, that reduction, and you're stopping that. You're absolutely freezing that up. Now, I've never had to do that, but I can guarantee you that that's, chemically speaking, that's perfect. That's like a no-brainer. That would work perfectly because I do it with prints, right? You've seen it with collodion chloride prints. So unless you're having, maybe in the field, you might want to employ that, right? Maybe in the field, you might want to put a pinch of salt in your stop bath water, your arresting water. Yeah, so up on the mountain, what I'm going to do, Craig, is I'm going to, because my well water, and I've checked it, my well water is 47 degrees Fahrenheit temperature, and it is 0 ppm and pH 7, meaning parts per million. There's nothing in it. Parts per million, there's nothing in the water, and the pH is 7, so it's neutral. So what I'm going to have to do is if I were to put a colloidal chloride print in that water, it'd just sit there. Nothing would come on. It's distilled water, basically, right? So what I'm going to have to do is throw a pinch of table salt in that tray, dissolve that in there, and then put the print in and pull it up. That's what it binds with that. So to answer your question, you're putting a chloride in with silver iodide. It's going to bind and precipitate silver chloride out. It's going to arrest. It's going to stop development, and it's going to pull any of that free silver off of there. So that's a great question.
Try it next time.
Yeah, try it and tell it. Come back and report and see how it works. Had problems with my tap water leaving stains on the plate. Okay, switch over to rainwater. Must have a chat with my local water company and see what they're putting. Okay, Peter, that's a great question or a great comment. Simply for the fact that we have a similar. I'm going to put you up here. We have a similar issue when we're talking about making or mixing chemistry, right? So you could take. I have a simple TDS meter. You could take a glass of your cup of your water and put a TDS meter in it and see what your parts per million. Generally speaking, over 150, I say you've got, if your tap water reads 300 or 400 ppm of whatever it is, I guarantee you're going to have stains on using that for arresting development. I don't have that problem even with my tap water for positives. But check that out, because at the end of the day, you can, strong enough, I mean, you're pouring, if it's your water, you're pouring that water on, if you have enough material in that, you can interact. I mean, that plate is still sensitive to some degree, right? Until you get that iron washed off, those compounds will mix up. And yeah, that staining is I've seen it on prints before. I've seen people, their water trying to steps in prints where not colloidal chloride like I was talking, but like albumin prints muddle up and stain quite easily. Salt print, things that can embed quite deeply, sometimes have that problem. Yeah, absolutely. Check that out.
The rainwater here is about 6.9. It's not exactly 7, but it's pretty bang on.
pH is no problem there, Peter. What you'd want to look for is ppm, parts per million or parts per billion, and a simple total dissolved soluble, a TDS meter. You can find them at pretty much anywhere, on Amazon, anywhere. They're simple and cheap. And just see if you're over, I say about 150, 200, if you're over that, you'll either have to, yeah, use rainwater. You probably have a lot of that there, but use rainwater. Use rainwater or boil off some water and set it aside a few liters at a time or something. But rainwater is good. But it sounds like you probably do have something heavy material in your water.
They started the local water company started experimenting with solvent to reduce the lead content in the water for Limerick City. And this has only arisen for within the last year.
Wow.
I don't know the exact compound, and like I actually don't drink the tap water here.
Oh wow. Okay. I think you probably found your reason, but it would still be interesting to see if you did a TDS in there and said, "Hey, I'm getting 600 parts per million in my tap water. What's up?" And then moreover, what is that they're putting in it is really, yeah. What kind of staining did you see on the images?
It was just it was like veiling and scumming. I sent you an email about it maybe a few months ago. And,
okay.
So you put me on the right track. So I started kind of taking particular elements of the process out, like kind of trying to eliminate probable causes. So I done a few tests with just distilled water. None of the problems arose, so from that, then I kind of just deducted it was my tap water, because like
good gum chewing. Yeah, that's great, and this is rare, guys. This is very, very rare that you'll have a tap water so high in total dissolved TD or ppm, parts per million or parts per billion. Parts per million is best, but that's rare that you'll have that kind of problem with rinse or wash water or stop water, because that has to be off the hook high, or with many many compounds, or the types of compounds are using to try to solve the problem. So yeah, that's very, very interesting.
Like some of the times when I'd wash under the tap, it would leave almost they were almost like developer burns.
Yep. Yeah, that's exactly, because that makes sense. That makes sense. I've seen that on prints. It's interesting you mentioned that, because I can take in the dark room, I can take a collodion chloride print. I've noticed this before. I'll have it in the pan, and if I put the faucet over and open the tap up, and that tap hits one area that has enough chloramines in it, it makes a spot there. I mean, I can eventually wash that through. It's not really, it's very active. So you have to watch those things, and that's a good point. So you guys listening that you have problems with those things, don't rule out your tap water until you've tested it, because it could be that tap water for sure. That's excellent. So the other part of the development process is that after you develop, you reduce the highlights, midtones, leave the shadow areas or void areas alone. Put it under the tap water, hopefully, or distilled water, whatever you're using. And you want to, one of the indicators for that is you get those rivulets again. You get those kind of greasy legs, if you will, again. And so we know it's arrested or stopped when the water skims out, just like in the silver bath, when you're sensitizing it. You know it's sensitized, it's the same process there. So people often ask me, how long do you go after you see those legs or rivulets gone, after when you're developing, how much longer do you go? This is my theory. I go another 20, 30 seconds, nothing extreme. And usually what I'm doing is I'm taking a cotton ball and maybe wiping off the back of the plate. I'm cleaning the plate up. I'm just letting it run a little more, a little extra, if you will. And why is that? Well, number one, I like to have a super clean stopped. I don't want any iron on that plate. All I want on that plate is collodion holding the reduced silver, the highlights and midtones, and then just plain collodion on the void areas. I want nothing else on that plate when I go into the fix. And I use potassium cyanide to fix my images. So remember what we have in our developer? We have glacial acidic acid in our developer. Now, I don't know if you guys have ever seen this. I've seen it a few times in workshops. People will get a little anxious they develop their image, they stop, they put it under the tap or pour the water on it, and they don't do it quite enough. and they throw it in the fix, and in this case, KCN. And sometimes it happens with sodium thiosulfate, depending on the percentage of it. And you'll get a blue haze, or you'll get blue corners. What that is, that means you have iron on that plate, because iron and potassium cyanide create Prussian blue, the color Prussian blue. And I've had plates streaked in workshops in Europe. I had plates streaked with Prussian blue. So that means they still had iron on their plate. They didn't wash all that iron off. And so it means they also had acid on the plate, which acid and KCN combined, they form hydrogen cyanide gas. That is not a pretty picture. We already know the result of that. I don't know how much it takes. I don't want to find out. I don't want none of that. So it's really important that you go that little extra step. Even though you see it, the legs are gone off after developing, go ahead and rinse it a little longer, or let it sit in a wash pan for a few extra seconds or whatever, 20, 30 seconds, something like that. So like I said, once you have that developed and you're reduced all the silver iodides and silver bromides to the pure metallic state of silver, you can now, and it's arrested, right? There's no more iron on it. There's no more acid. The alcohol is gone. You can now go into your fix. And we'll do a whole segment on fix too. But real quick, what does fix do? Fix removes all the unexposed silver from that plate. So if you've done a good job, I did leave out when I talked about arresting the development under the water. All I want on there is the reduced silver and the collodion. What I forgot to mention is the entire plate is still covered with silver, right? Unexposed silver. So you have to remove that. So there is that one component. But so when you put it in the fix, that blue quote negative that you get, if you're doing positives, you put it in the fix, that removes all the unexposed silver. Now, how fast and how efficient it is depends on the strength of your fix, the temperature, the type of fix, all those things. Just real quickly, and I'll reiterate this in another show, fix tends to fill up just like in the film world, right? Remember the old roll your film up on spools, whatever size, whatever format you're working with, and your fix exhausts. What that means is that your fix, the ions, the molecules in there, whatever type of fix you're using has been replaced with silver, because that's what you're removing from the film as well. And so that's why you talked about exhausted fix, taking it down and reclaiming the silver from it. Well, here's what happens in cyanide. KCN, potassium cyanide, once I put 20, 30, 40 plates through there, you can read in my book, it's on the fixing side. You can read in this about my methodology of how do I tell when my fix is exhausted. When I hit 15 seconds for it to clear, I do another 15 seconds for a total of 30 seconds. That's when I feel like my fix bath is now exhausted. Is it really exhausted? No, not completely. It's not. But if I'm making serious work or important work, or work that I'm selling, or work, whatever it is that's important, I don't want to risk the chance of having some silver on there that'll process out and turn black. So my cutoff is 15 seconds for a total of 30 seconds. What does that tell me? Because the first plate I put in a new fixed bath for KCN takes about 4 or 5 seconds. I count off again 4 or 5 seconds, and it's cleared and good. Well, what happens over time? Each plate you put in there, depending on the size of the plate, the amount of cyanide you're using, that replaces that KCN, turns to AgCN, or silver cyanide. So the potassium molecule or ion is replaced with this Ag, the silver, and it plugs up, and it's like having a room that's 10 meters square, and each person you put in there fills the room up more and more until, my God, I can't fit another person in that room. So that means that person's going to be standing outside. That's the silver that I just gave you an example of. And if you don't get it fixed properly, you're going to develop that or process that silver out, and your plate will turn black. So if you don't have the proper fix, and you don't have the watch for that, whatever fix you're using, it doesn't matter. Sodium thiosulfate, ammonium thiosulfate, sodium cyanide, potassium cyanide, it doesn't matter. You're going to fill that up eventually. And that's my rule. It may be you might be able to get, I've read in the old literature 20 or 30 seconds, and then another 20 or 30 seconds, whatever. But my rule is, it goes so long and so far, I just don't need to mess with it anymore. And then I have a process in the book, if you do use cyanide, how you can eliminate that cyanide molecule and turn it into a cyanate molecule and get rid of it. But anyway, so that's the developer. Let's talk about when you're making negatives and you have a thin or an overexposed ambrotype that you want to turn into a negative and you need to redevelop. Let's talk about what redevelopment is. There's two methods, and if you read the old literature, and I've read most all of it, if you read the old literature will tell you that intensification and redevelopment are basically the same thing. But in today's vernacular, or how we talk about it, I separate the two. I say redevelopment is with pyrogallic acid and iodine, and intensification is a sulfate bromide bleaching silver nitrate bath. And I'm going to explain both of these to you so you understand them. Hello, I just said hello from Fluland. Hello, everybody. Yeah. Let me see if I can get everybody in here. Oh wow, we got a nice room full. Way to go, guys. Good seeing everybody. Good seeing everybody. Sorry about not recognizing you earlier. Can we put up the gallery view? Yeah. How about that? How about the gallery view? So let me talk about let's talk about redevelopment first. Redevelopment is the process of taking that bright ambrotype, that ambrotype that I just mentioned a minute ago. A lot of the images I see online now are overexposed positives. You would be great to take one of those and do this process with, because you could make a negative out of it. So an overexposed ambrotype or a bright ambrotype gives you enough silver on the plate to pack on some density, pack on a little more silver and stain that silver. So what we're doing when I purposely overexpose, let's say the X factor, let's say my perfect negative is 10 seconds. I don't know that at the time, right? So I do some tests, I make a nice ambrotype, it's 4 seconds. And Frederick Scott Archer said it double that time. For a good ambrotype or a positive and you want to make a negative, double that, time and a half or double. Let's say we double that and I go to 8 seconds. I go to 8 seconds. I can take that bright ambrotype now at 8 seconds, and if it's still not quite dense enough for an albumin print or a salt print or something like this, I can now take it into the darkroom and redevelop it, meaning that I'll add more density to it. So it has more bulk, it has more silver, and the silver that's there, I build up and I stain it. And what do I use to do that? I use pyrogallic acid, citric acid, iodine, and distilled water. And here are the steps. After my bright ambrotype, my 8-second ambrotype, and I don't know that it's 10 seconds, right, to make that perfect negative for printing out. I'm still working on that. So I take that 8-second ambrotype. We know it's double the exposure or time and a half the exposure of a good ambrotype. And I put it, wash it, and then I take a very dilute solution of iodine and I pour it over. I put a meniscus or a layer of iodine on that and I just work it in. And when that iodine changes color from that reddish kind of color down to a neutral water, I just drip a little bit off the side onto a white pan. When I see that iodine is soaked into the silver that's on that plate, I go ahead and rinse it just like I do arresting development after making a plate. And you'll see those same rivulets, you'll see that same process. And I do that until those rivulets are gone. I don't overdo it, I just do it until the rivulets are gone. Then I take it out in the nice bright UV light like we have today, or under a black light if you're in the winter time, or under a screen printer, whatever it is, and give it a good dose of 30 seconds or a minute of that UV. Right away, you're gonna see that density pop up. You're gonna see that density start building right then. Why is that? What happens when you pour iodine, even a weak solution, when you pour iodine on pure metallic silver, what do you think happens? Anybody? Anybody want to chime in? What happens to that silver? I'll give you a minute. Unmute yourself and jump in here.
Become sensitive to light again.
Excellent, excellent. iPad, tell us what that means.
Well, you're rehalogenating the silver over there?
Perfect, perfect. Iodine and metallic silver, that's exactly right. Iodine and metallic silver creates AgI, silver iodide. No, it's not in the most strong absolute form, but it does start that process of creating the light sensitive. Rehalogenation is a great word for it. And that is where you can now, that's why when you expose it to UV, guess what it's doing? Building up. It's producing, it's exposing, it's hitting that, you're printing that out basically, right? Then we take it back in the dark room, and I love to show this. I love to show people when they're in the dark room and they see the bright ambrotype. We start off, I said, get your phone out. They do a snap of it in the white tray. And then they start working on it. They put the iodine on it. They expose it to light. They put it back in the pan. Say, snap it again. They snap it again. They're, whoa, wow, that's getting dense. Now we take pyrogallic acid with a little bit of citric acid, and the carrier is water. This is our redeveloper solution. What is pyrogallic acid? Does anybody know what pyrogallic acid is? Chime in, unmute and chime in if you do. No, that's fine. Do you? Anybody? No? Okay.
It's a stainer.
That's a stainer, exactly right, Tim. But do you know what the compound is, or the chemical is? How it's made? Or what is this pyrogallic acid? What is this crap, right? Pyrogallic acid, believe it or not, remember my book cover? This is, here's a gall nut. It's gall, heated, very high in temperature, and it creates pyro, as in pyromaniac, gallic acid. It's from the gall nut, and it's heated up way high. So that pyrogallic acid isn't really it is a developer. And again, here we go with these terms. So I want to be careful so I don't piss anybody off. It's a stainer, like Tim just said. It's really a stainer. And I'll tell you the difference between using a reducer like ferrous sulfate, iron, right? We just talked about that, and a stainer like pyrogallic acid. So think about what's in our redeveloper. We have a gram or 1 to 6% pyrogallic acid in our redeveloper, and about 8% citric acid. What do you think the citric acid is for? Anybody? Anybody got an idea why you would put citric acid in that redeveloper? I'll give you a second while I get a drink. What's the glacial acidic acid in regular developer? What is that called?
Well, the gallic acid is well, it's a restrainer.
The citric acid, though. What's a citric acid, Tim?
Wouldn't that be a restrainer also? But
you got it. You got it. That's exactly right. Here's the problem with understanding what this stuff is. The gallic acid is not a restrainer. The pyrogallic acid is a stainer, or we can call it a developer if we want. Just to clear our heads, we'll call it a developer. So the pyrogallic acid, that word acid really throws people off because it's not a restrainer. It's actually a stainer or a reducer. Doesn't really reduce. It's similar as ferrous sulfate in the positive development or negative development process. So the citric acid is the restrainer, holds back so you can do your dance when you redevelop. The pyrogallic acid is the stainer, and the water is the carrier. So now we've put iodine on the plate. We've washed a little bit of that off. We've exposed it some great UV, built a little bit of density there, and got it open and ready to take this stainer on. So now we take that stainer and that citric acid, the pyrogallic acid and citric acid in the distilled water, and we add a few drops of 9% silver nitrate. So now we got a bomb. We got a mixture of all these things happening. We pour that on that exposed open plate, and guess what it does? Builds that silver up, makes it dense and heavy, adds to it, and it builds density. And you can see this so easily as you pour cup after cup on. You drill it off, pour it on, drill it off. I have a little process, you know, like wax on, wax off, like the old Karate Kid movie. That's what we do. We put acid on, acid off, acid on, and restrainer on, restrainer off. Or redeveloper on, redeveloper off. And I have a little process that we start with a clear solution. I do 40, 60, 80 mil cups, something like that. And we start with a clear solution. And by the time that solution is red, it's pulling all that iodine off that silver and staining it and replacing it, adding silver to it and staining it. And people often write me and say, hey, can I use, you say I can use ferrous sulfate in place of pyrogallic acid. I don't want another dangerous chemical in my setup. Yeah, you can do that. You might have to go a little longer or mix the solution a little stronger, but that reducer works just as well because you've set it all up to reduce and build that silver, and you're adding silver, your silver nitrates in there, your ferrous sulfates in there. So you've got your silver and you've got your reducer, and you're putting it on a plate that's ready to take all that on. That makes sense to me. I hope it does to you guys. It's a one I love. People say, oh, you don't need to redevelop your negatives. No, you know, if you're lucky and you get that 8-second exposure that's really supposed to be 10, what I'm doing in the dark room, going back to our analogy, is I'm adding those 2 seconds chemically with redeveloper. That's what I'm doing. And I'm doing that safely. How am I doing that? How am I doing that safely? When I say I'm doing that safely, what I'm saying is I don't know that that's a 10-second exposure for that negative, but when I get it in there at 8 seconds and I redevelop it to 10 seconds, that means I don't run the risk of overexposing that negative, okay? What happens when you overexpose a negative? You start to lose density. You go the other way. That's why people say, well, Quinn, you want a dense negative? Just take that cap off, open your lens up, and go for it. 30, 40, 50-second exposure. Do that. Watch what happens. Even a second or two over, you start going the other way. You lose contrast. You lose density. Overexposure with a negative is deadly. Overexposure with a positive is a different story, right? We just talked about that. Because let's be honest, this process was never a positive process. This process is a negative process. That's how it was invented. That's how it started. We added, well, human beings added, we didn't, in the mid-50s, 1850s. We started understanding that, wow, that underexposed image against something black looks great, right? So this was never a positive process. It was always a negative process. The intentions of it were to make prints, always. For you film guys out there, I know there's a lot of you. I remember taking, I shot a lot of 35 millimeter and 120 film, and I'd develop my negatives, and I'd be looking at my negatives like this, and I'd have an underexposed frame, and there'd be something black behind it and some light behind me, and it's, oh my God, that's a positive, you know? That's what this is. We're underexposing a negative using reflected light with something black behind it and making that a positive. This was never a positive process. So everything coming from the 1850s, the early 1850s, Frederick Scott Archer and those boys, was all about negatives. Can you replace a pyrogallic acid? Yes, yes. Yes, you can, Martin. You can definitely do that. And the only thing is you may experiment with this because there's a lot of latitude in here with redevelopment. I recently, in this latest book, people call me out on this. They say, hey, your redeveloper is like 6 times as strong as your other book. And I recently when I was writing this book, I started reading that old literature on redeveloper, and man, some of those boys would go 8, 9%, not 1%, like 1 gram per liter is 1%. They're actually 0.0, 0.1% rather. Some of those old boys would go up to almost a whole percentage, right? They just pack in that pyrogallic acid. I don't want to go quite that strong. I recommend about 5 or 6 grams now per liter. There's a lot of latitude. The only difference is going to be is you're going to have to do it a little bit longer. I found it safe for me to add between 6 and 8 grams per liter, 0.6, 0.8%, and redevelop just fine. I don't have any issues with that at all. And it goes quicker and it's a little longer. Oh, that's a good question. Can you refix for a short time after redeveloping if you get too much density? Really, it's so visual. That's a great question. You can't. You could, but it's not going to remove any of the unexposed silver like traditional fixing does. So what you're doing here is you're visually inspecting, and you'll know by just using transmitted light. You can do this in light, no problem. You'll know, you don't want to do it outdoors, but you know what I'm saying. Good low light, white light you can see. You'll know when you have enough density. When you know you have enough density, it depends on what kind of print you want to make. You have to have all these things, forethought, you have to have planning, you have to know what you want. Because if you get in there and you just try it, go as long as you want. I've made negatives, so I mean, glass and black, period. I just pushed it, and it will go. It will get really black and dark. You can get, density of 3.0, 4.0 on a densitometer. It's crazy. You can stain that silver there to where zero light penetrates, and that's a dense. That's what we really call bulletproof. You never need that for printing out. You never need it. But I always like to do, even if I went out in that 10-second perfect negative, even if I went out and I didn't know it was 10 seconds and I got lucky and I guessed it was 10 seconds, and that foundation negative that comes out of my camera, it's a perfect negative, I don't need to redevelop it. I could print it. I could do, let's say it's for a salt print or albumin print. I could just do that, no problem. I wouldn't need to redevelop it. I'd say 90+% of the time, I'll take 20 mils of redeveloper and 3 or 4 drops of silver nitrate, and I'll run a couple of cups of redeveloper over it. It just tends to sharpen things up, just snaps those negatives up really nicely. Let me grab a negative or two. Let me show you what I mean here. Sorry, hold on. I think I have a good example of this here. I think I do. I should have planned for this and I didn't. Because I need comparables or they won't make any sense at all. They're not the same image. I don't want to spend any time looking for. I've got the gallnuts redeveloped and not redeveloped, but here's a good example. I want to pull some paper up so you can see these. So one of these images, and they both print really great on collodion chloride. It just takes a little longer on one than the other. Here's some white paper. So here's the, wow, good varnish job, Quinn. Here's the not redeveloped image. Okay, which is a good foundation negative. That's your 10-second negative that would print just fine. But here's, let me see which side is which here. Here's a redeveloped negative. See the difference in those? I mean, it's striking. I wish you could see them in person, but I wish I could hold them up. Maybe I can. This is
Quinn, if you had 2 negatives that were, of the same image, and one of them has been redeveloped, one is not, and you print them with the appropriate time, can you see any difference in the resulting print?
Yes, you can. That's really great point. Great question. And my point is sometimes if I didn't have those, and I have the gallnut and the rabbit skull, I have one good exposure, not redeveloped, and one redeveloped. And I print them both. They both look great, but if you hold those prints side by side, the one that's redeveloped is a little snappier. It's got a tiny bit. It's for critical eyes, but I can see the difference. And I just find that I'd rather go 2 or 3 minutes longer in the Ryonet on a print and get this kind of negative versus this. And moreover, this will not print on salt or albumin. This will. It gives me wider possibilities of printing. This looks great on collodion chloride, and this looks great on collodion chloride. This wouldn't look that great. I mean, I could probably pull a salt print out of it, but maybe, I don't know. I haven't tried any. But I just encourage you to find your workflow and find out what you want to do and how you want to do it, and then play with a little redevelopment and no redevelopment. The problem with no redevelopment is you've got to have that foundation negative right on. You need to know what that particular exposure is. Here's the problem, guys, ladies and gentlemen. The problem is this. When we go outdoors, and let's be honest, to make negatives, you need natural light. For the most part, you need to use natural light. Let's be honest, because artificial light is great for positives, but it's not really going to give you the best negative. Can you do it? Yeah, I've done it. It's not that great. It's not comparable, right? We're talking primo negatives here. So number one, you're using the natural light. Well, guess what? The Earth spins and rotates on its axis, right? So we're chasing that light constantly. So we don't have a fixed time every time. You'd have to document every day and make plates as the Earth rotates and spins and changes light and how much cloud, how much pollution, all that stuff. We just don't have that ability. So what this redevelopment gives you is you can climb up close that 8 seconds and then add those 2 seconds on chemically and watch it. Like, I just want a collodion chloride print from this. I don't want salt or albumin. Well, just do, a 20 mil cup. Or I want salt and albumin from this. Well, then you're going to have to do an 80 mil cup and do it a couple of times and really pump that up a little bit. And you don't have to worry about overexposing outdoors, chasing that light, trying to get that foundation in negative, right? A few people over the years have called me out because I've been such an advocate of redevelopment. No, you don't have to redevelop. That's BS. Don't listen to him. You're right. I'm not going to argue with that. You don't have to redevelop. If you're that good and you spend 12 hours a day like those old boys did back in the day and you got this stuff down like that, you're probably good to go, right? Most of us just don't make 15 or 20 plates a day, right? Most of us don't do that. So we have to find our little workarounds. And one of the workarounds is redevelopment. And that gives you that ability not to chase the light, still make a good exposure, build that density up to print out whatever you want to print, knowing what you want to print out, and work from there. So redevelopment is my absolute favorite. In my old book from 2006, oh, here's a great question. Jan's asked, can you redevelop after the plate is dried? Wonderful question. Excellent question. Let's talk about that. Every single one of these plates that I make are albuminized, meaning I prep the plate, I cut it, I deburr it. These all happen to be 15 centimeters or 6-inch plates, glass plates. I clean them, I do all that stuff. I've got my trusted plate cleaner here. Need to mix it up a little bit. Do all that stuff. Then all of these plates I've actually completely albuminized. So sometimes I'll just edge the plate with albumin, right? It's called edging albumin. I'll just take a Q-tip and just run that around and let it dry and make sure it's sealed up. Or I'll put it over a humidifier and pour a solution of albumin off, put it on the rack and let it dry. You get a little better results, a little more density. This is fully albuminized. You get a little more density when you albumin. The density here doesn't come from the albumin. This is the redeveloped, not redeveloped. So to your question, if you've albuminized, and especially completely, and you let that plate dry, you probably are okay, and your glass is clean, all that good stuff, you're probably okay to re-wet it and redevelop it. I hate to say that publicly, because the first person that's going to try it and he has his plate peel up, they're going to email me and cuss me out. But here's the thing: if you've done it properly, you should be able to re-wet that. What happens with collodion? Think of collodion as like a plastic. It dries, shrinks, and expands constantly. All that. So if you have an edge that's not quite connected with albumin, and we know what egg whites do, right? They hold that stuff down. You ever seen egg whites on a car peel that paint right off? That egg white's not going to come off without the paint. So if you edge that, if you put that around your plate or submerge it completely or cover it completely, I'm going to say you're probably 99% sure that you can re-wet that. Yes, the collodion will move a little bit, but it's going to be stuck down and it won't lift on you and curl. That's the danger you run. Once a plate, and this doesn't happen with aluminum or tin, but once a glass plate is dried and then re-wet, most of the time that collodion is going to shrink and it contracts and it peels right up off the edges. So great question though. That's how you get around plate is dried and you want to redevelop it. Just make sure planning is key here. Just make sure you've planned it out and make sure you've albuminized that. So redevelopment is one way to do this. What's the other way? The other way is what we call today intensification. And if you read the old literature, and I encourage you to, excuse me, if you read the old literature, and I do encourage you to read that, any of those, go on Google Books and just search wet collodion. Get you a nice big library up there like I do, and just pull up books and read them. I've got a lot of them printed out now too, over the years. But in the old literature, you'll read that intensification and redevelopment kind of meant the same thing. Today, we use it a little differently. There's two different processes. I do not publish this process any longer. In my first book in 2006, I actually published this intensification process that I'm going to talk about. Intensification is basically doing the same thing. What you're doing is you're adding density to a plate, to a negative that you want to print out that requires more density than you have. And that's what redevelopment is as well too. But it's a different methodology, it's different chemicals, and it's a different process in general. What do you do here? So you have this, this is right out of the camera. This is called the foundation negative. You pull it out, you have it. Yeah, that's a bright ambrotype, right? There's a bright ambrotype for you against black. You have this negative, because it's not a positive, does not look good as a positive. You have this negative, it's underexposed for making an albumin print, and you need to add density to it. Well, you can redevelop, like we've been talking about for the last few minutes, or you can intensify it. What's intensifying? Intensifying is a process that you mix copper sulfate and a potassium or ammonium bromide, a sulfate and a bromide together, and you create what's called a bleaching solution, So that copper, a lot like ferrous sulfate, that copper and that bromide go into distilled water, and you put your plate in and you bleach. The old literature says you bleach the highlights white. So these highlights will go white, all the highlights on your plate. Bleach through to white is what the old literature says. And what they're saying there basically is just like the iodine on redevelopment, you basically will use these words opened up, that's silver. Remember, that's metallic silver there. We've opened that up. We're ready to take on light, take on chemicals or compounds, etc. So once you bleach that, white, you then have another pan of silver nitrate. It can be 6, 8, 10, 12%, depending on how intense. And the bleaching time too, you can bleach this mildly, use a mild or a low percent silver nitrate and just bleach mildly, like I was talking about redevelopment, just like a 20 ml cup, just a real quick touch. But once that negative is bleached, that silver on it's opened up and ready to take on a compound, you put it in a pan of silver nitrate, and it just builds up all the density that's there. Everything, any of the silver that's there, it's going to build up, just like redevelopment, right? But it's fast. It's just a couple of seconds. Here's why I don't like intensification. Well, I don't want to say I don't like intensification. Here's why I don't recommend people that are first going into this to use intensification versus redevelopment. Number one, control. Period. Control. Number two, cost. Now think about a pan. Say you're doing 20 by 25, 8 by 10 plates, 20 by 25 centimeter plates. You need a pan that's going to accommodate that, and you need enough silver nitrate in there. You're talking at least a liter in there, right? At least a liter in the pan to cover those size of plates. that's, you know, in the US, that's 100 or 110. Well, now silver's gone down quite a bit. I don't know. It's between 90 and 100 US dollars. And you commit to that, and all you're doing is intensifying negatives. That's a big commitment, right? You could cut that in half, do $40 or $50 bath with the silver. The sulfite and the bromide is the cost is irrelevant, the bleaching solution. But the first thing is control, then cost. I'll talk about control first. Control. You go in the dark room, you have your plate, you have your solution of pyrogallic acid, citric acid, distilled water, and silver nitrate, drops of silver nitrate in there, pour it on, pour it off, pour it on, pour it off, work it around, pour it on, pour it off. You build up, you visually watch it. Oh, I want to stop right there, or I just want a little bit, or I want a lot. You control how much density you put on that plate. You arrest it, you wash it off, you clean it up, you're good to go, you varnish it, you're ready to print. What does that little bit cost you? You're talking about 4 or 5 drops of silver nitrate, 9% silver nitrate, versus, you know, a liter or a half a liter or whatever. The cost is tremendously different. You can do redevelopment and just commit, you know, a couple of 100 mils of silver nitrate, and you're good to go for, God, I don't know how many plates. I got 52 of these. Every single one of them's redeveloped. And I don't know that I used, I don't know, 100 mils, 150 mils of silver nitrate, maybe tops, you know. The closer you get to that point, the less silver you're going to use. So control, being able to visually watch that on, off, look at it, inspect it. Okay, I want to stop it there, wash it off, varnish it, off you go. Versus on cost and control secondly into the silver bath after you bleach that, boom, it's going to do everything immediately. It's just going to pop everything, build everything up. No problem with that. I've had good success doing that, but I've just found it's easier control-wise and cost-wise to redevelop. So those are the two methods of redeveloping and intensification. And again, I don't publish that intensification everywhere. Hey, Sasha from Germany. Welcome. Good to see you. I put up a file earlier. Can anybody, I don't know why, if I share my screen, I try to share my screen and it tells me open, system preferences, security, and privacy. Okay, security and privacy. Let me see if I can share my screen here. Security and privacy. Let's see. I want to share my desktop. How do I do this? Privacy, how do I do this? Accessibility, camera, phone, files, automation. Everything's shared here that I can see. I just wanted to share an image with you and show you the difference here. In desktop folder, yeah. Full disk access. Let me just see if I can share my desktop. Huh. I'm going to have to work on this one. I should be able to share everything here, and I'm not sure why I can't. Microphone, camera, location services. Why can't I share anything? Camera. Huh. I don't know why I can't share my desktop, guys. Anybody have any idea? Anybody worked with this before? Screen recording, no. Anyway, I was going to share, I put it up in the chat. You can look at that. I'll put it up there again. Your computer. Here's a little example. This is like a 2 cup or 3 cup redeveloper. I've got it pulled up now. You can see not redeveloped and redeveloped. Pull that file up, you can see it. It's under red, so it's not that great of an image, but so yeah, you can redevelop or intensify underexposed negatives, knowing what you want in the beginning, and go from there. Because it's really, really what it is. It's knowing what you want to do, is how much you want to work with that or not. So is there any questions on that? If not, we're going to move into some of these questions that I got over the week here. Throw me some questions if you have any on that. I'm going to grab my waxing box here. And where is it here? Here's my waxing box. What is my waxing box? My waxing box. I had some questions. Thank you, Jan. It's not too bad of an example. I mean, you get the idea. Everybody kind of knows that, you know, everybody knows that what redeveloped and not redeveloped images look like. Those are pretty good examples of them here anyway. So I'm going to set these to the side a second so I can put this stuff out. I don't want to break my negatives though. Put that one there. This is my waxing box, and I'm going to just show you guys. I got some questions. I don't think Dale is in here, but Dale from Canada and Marianne from Denmark wrote me and said, hey, can you talk about waxing salt prints? How do you wax salt prints? What do you use? What's the methodology there? And I said, yeah, I can bring that up. I can show you what I use. I don't know why I don't have lavender oil in here, but I have some over on the shelf. So this is my waxing box. I'm just going to bring a couple items out. First off, let's talk about what waxing a salt print is. I think it's really, really important, kind of like toning a print. I think it's really important to wax your salt prints. You can wax any print, but salt prints tend to have. Let me answer Rusty's question. Off subject a little. No, it's not. This is just open. I'm just answering questions. So you guys throw out anything you want. I'll try to answer it for you. Rusty says, off subject a little. What we know the cons of potassium cyanide fix. What do you like about it? That's a great question. I think I'll answer Jan's first. And iodine, you just look for color change. Let me answer Jan's first, since we're still kind of, our heads are still a little bit into redevelopment. What that is, Jan, is you pour that meniscus of diluted iodide. Use distilled water, by the way, it's the best, or deionized. Put that meniscus of iodine on that image. And what you're looking for is a color change both in the solution, meaning that it will lose that red color and you can just drip a little bit off. I usually use a white pan. Just use that, drip a little off until it looks like water. And also, if you have a negative that has a lot of highlight in it, you'll see that silver change colors. It'll go to like a gray purple color. So between that gray purple color and then losing that color in the iodine itself, you know you're ready to put it under water and kind of wash that off until it's not greasy anymore. So that's what you look for. It is a color change, and it's also a shift in the silver on the plate itself, because it's actually, like the gentleman said earlier, it's rehalogenating. It's actually interacting with the silver. So to Rusty's question, why, we know the cons of potassium cyanide fix. What do you like about it? We do know the cons about it, right, Rusty? We know that it's very dangerous, and that we never want to get it by acid. We never want to have it lying around. We never want to keep it in glass bottles. They break. We don't want any of that. We know all the cons of it. It's very dangerous. Absolutely correct. What do I like about it? The first thing is that I do a lot of field work, meaning I'm out in the field. I'm out with my dark box. I'm making images out in the field. I like a quick and efficient clearing of that plate, meaning removing all that unexposed silver as quickly and as efficiently as I can. Sodium thiosulfate works fine. Ammonium thiosulfate works fine, but it's not as effective as cyanide. It's just not. Cyanide doesn't penetrate that deep. It quickly dissolves, dissolves basically that unexposed silver. It loves to eat up silver. That's why if you leave it on too long, it'll get rid of your midtones too. In a strong enough solution, right? So it removes it quickly and efficiently. And it's really important because I'm outside in the UV. I want to make sure I do that. I don't want to leave any unexposed silver on the plate. And then moreover, more importantly, I have a tiny, tiny fraction of the wash time that I need for sodium thiosulfate or ammonium thiosulfate, meaning that I carry 20 or 25 liters of water with me in the field, and I have to make that work for 10 or 15 or 20 plates. I couldn't do that with sodium thiosulfate if I used one of the traditional fixes. So, because it takes much more, it embeds, it takes a lot more to, and if you leave that in there, if you leave that silver decomposed with that thiosulfate, it's not going to be a good scenario in a week or two or a month or a year for that plate. It's just not going to be good. So it's fast, it's effective, and my wash times are a fraction of what they are with sodium thiosulfate, especially for the field work. Secondly, there's a spectral or a sensitivity that's better for negatives. And I would even say positives too with cyanide. You get a better color if you like that kind of warm color. Somebody posted on the board the other day, why are some of the images warm and some of them are silvery? That has a lot to do with how much developer you use, if you catch a little silver on the plate developing, and what kind of fix you're using. Sodium thiosulfate mixed at 10% or 15%, or ammonium thiosulfate, you're going to get, well, ammonium is a little bit different, but your sodium thiosulfate, you're going to get a cooler color, a more silver color, a more traditional gelatin silver color print or image. Cyanide, you're going to get a warmer color. You're going to get, the colors behind me kind of thing. So having said that, that's what I like about cyanide, and I love it. I fear that they're going to take that away from us someday. I hope they don't. I hope they don't. I don't know that I'd work in the process if they did. So back to fixing prints, or waxing prints. And I'm going to specifically talk about salt prints because that's traditionally what we wax, right? Or salt prints. I got my waxing box down. I do all these processes in boxes, or I compartmentalize everything. So my albumin box is up there, my salt box is up there, my waxing box is up there, that kind of thing. What is waxing a print? Basically what we do, when you make a salt print, most of the time, not all the time, but most of the time, you're embedding into the material to some degree. That makes them kind of have less density, a little more flat. Yeah, kind of lacking contrast, if you will, a little bit. Not always, but sometimes. So generally speaking, what we want to do is we want to pop that up. And a good way to do that is waxing, using beeswax and lavender oil. And the beeswax, let's talk about that first. I use only white, clean, nothing in it beeswax. Be sure you don't have anything in the beeswax. White beeswax, clean beeswax. Lavender oil, it's the same lavender oil you put in your varnish. Hopefully you put lavender oil in your varnish. So what is the beeswax? The beeswax would be the, we can basically we could call it as the carrier, right? The binder, if you will. If you want to use emulsion terms, maybe I shouldn't do that. Somebody will call me out on it. But this is what's going to carry, this is what's going to cover your print. And you know what happens when you buff wax? It shines. Number one, it's a great, you put it over silver, you'll never have, it's a great way to archive, great archival, making archivability. It's great for archivability is what I'm trying to say. That was easy for me to say. And number two, you can shine it up and it'll glow and glisten and shine and it'll look really nice. Number two is the lavender oil. I have lavender oil right here. I probably pulled that out of here actually, to be honest with you. Have lavender oil right here. What's lavender oil? Well, it's the stuff we use in the varnish, and its purpose is the same here. The purpose in the varnish is what? It's a plasticizer. It keeps the gum or, shellac or whatever you're using, it keeps it flexible. That's what lavender oil does. And this is the real lavender oil. This comes from the bud, the lavender bud flower. And it has that wonderful smell to it. It's got that terpene in it called linalool. And linalool is known to mellow you out, right? That's why they put it in all the bath products. That's why it smells like grandma's bathroom, right? I hear that all the time. So beeswax and lavender oil. Those are the two things you want in here. I mix mine. I have a little dish here. So I have droppers for the lavender oil, and I have spoons for the wax. And you can see that I've heated this up quite a bit. I cut off the wax. I put a gob of wax in there, just a little bit, doesn't take much. And then I drop lavender oil. I melt the wax over the alcohol lamp. I have a little, my little spirit lamp here. So I heat this up, I melt the wax, and then I drop the lavender oil. You know, it depends on how big a print or how many prints I'm doing. The question was, what about what kind of consistency do you want with this wax? And I like to say, Dale brought up a very good point about applying it or brushing on it. A shoe brush works great. If you get a nice shoe brush, and again, what else is in my box is blue tape. I tape the print down on a piece of glass. I get the consistency right with the wax. I put it on. I put it on with either like a turtle wax thing or a cotton balls in white material. I have all this. I cut off this white material and I use it to wax prints with. And then you can buff it. Use a shoe brush to buff it. The consistency you want is like a shoe polish or a chapstick, or you know, there's all kinds of ways you could put this. But basically, you want it moist enough to go on. You want enough oil in there. After you melt the wax, you want enough to be able to get on. Don't put it on too thick, and then start buffing it out. Just wipe it over the print and then just start buffing it out. And you'll see, if you have it taped down, the unwaxed and the waxed portions, once you lift that tape off, they're tremendously different. You'll fall in love with it. If you do a lot of wax prints, I encourage you to, or salt prints, I encourage you to look into waxing. It'll change your toning, and waxing will change your prints forever. They're beautiful. So that's waxing. Anything on that? I put it on with a cloth and buff with a brush. Perfect, Peter. Yes, excellent. Awesome. Oh, let's see. I'm just learning this video stuff. So show us, Peter.
Well, no. So
Yeah.
it's just, I buy these in Lidl. They're kind of just a normal glass cleaning cloth.
Perfect.
They come in a set of two. So there's two cloths in the set, but I used a rough one to put on the wax because it can carry a lot of wax in it, and just rub it around in circles. Leave it dry for about 10 minutes, and then buff.
There you go. There you go. He's way ahead of me. Yeah, excellent. 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 That's the way to do it, guys, right there. And that'll save your arm. And oh yeah, let's see.
Well, you won't be able to see it, but this is tonight's little project, so I have to wax.
Great. You should show us next time. You should show us a before and after, and just let us rotate the light on them. You can really see that difference. Once that light hits it, you'll see a dull print versus a bright print. It really makes a big difference, right, Peter?
Huge difference.
Yeah. And you get the benefit of being a little more archival. That's
true.
That's a wonderful thing. Thanks for sharing that. That's awesome.
Peter, I assume that's a really soft brush.
It's not actually soft at all. I wouldn't class it as soft. It's just I don't polish shoes because I don't wear them, but boots is what I usually wear. But I would just call this a buffing brush.
Yeah, I call it a medium brush. Somebody asked me about that the other day. It's a medium brush. You'd be surprised. I think that's Pat talking, right?
Yeah, it is.
Yeah. Welcome, Pat. Where are you? Here you are. Pat, that I call a medium brush. In essence, those really super soft ones, you'll be forever and a day. You do need, just like Peter said, you do need like just a shoe brush, your typical shoe brush. They're not that soft. And so
interesting. Okay.
Yeah, you'd be surprised. I know. In your mind, you think, man, I don't want to be roughing up my print with that. You'd be surprised.
Exactly. They're braid the surface or something.
Yeah, exactly. Yeah. Good point.
You actually remove an awful lot of the excess wax that you don't need, and gives you a more even coating as well. And you can then you can even buff it up a little bit further with a softer cloth then if you wish.
Perfect. Yes.
Excellent. Thank you.
Yeah, these really good points here, guys. I love this. This is great. Share what you're doing. Give that information out. I have no corner on this market. I want everybody to get in on this and share their techniques, because at the end of the day, we're all still learning, and we should always should be learning, right? I mean, we don't nobody has a corner on this market. It doesn't work that way. I always pick something up here or there, or like whether it's an old manual or somebody sends me an email, hey, I'm doing this. Have you ever done it? Well, that's cool. Thanks for sharing that, So that's great. I don't see a lot of people using brushes. So thanks for sharing that, Peter.
So some of the times I'll put a coating of gum arabic on the salt print as well. This will yellow over time, but it gives you a nice base for the wax as well. And if you like the shine off wax, when the wax is applied over the gum arabic, it's actually glossy.
Excellent. Tell us what your mixture is on that gum arabic. What percent?
It's just Sennheisers.
Okay.
So it's off the shelf. I put it on with a brush. Very light coating with a brush though, and because it will leave streaks if you put on too much.
Wonderful. Yeah.
As I said, it yellows over time, but if that's something that actually adds a nice patina to the print. But yeah, it's good.
Excellent. Wonderful. That's great. Thanks for sharing that. That's awesome. That's the thing with the techniques. Everybody has a little bit different technique or something added. And as long as you know the caveats on it and you want to try, I think we're all in experimental phase here's my position, until you have a project, until you have an idea for a body of work that you want consistent, you want archival, you want this look and feel, experiment, find out what that is, find out how those things work. So excellent. Thank you for sharing that. Let's go back to the list here. So Marianne and Dale asking about beeswax and lavender oil for salt prints. Kind of went over that. Let's talk about Tim. Tim sent me some good questions. Adam Ramsey and Dale asked about redevelopment. We got that covered. Awesome. Tim sent me some great questions. Here's the first one Tim wrote. He said, when you finally, and he's in here, so he can elaborate if he wants. When you finally dialed in how to print a specific image, the exposure time on your RioNet. My RioNet's the screen printer. He's talking about printing out process papers. The amount of time, toning, how do you record this information? I showed this last time, but I'll show it again. It's just my little, what do we call it? My little, I know it says 2001, 2002. This is my little Collodion book that I keep notes and information in. My little, I just did 3. Probably the day he was asking me about this, my beer and Mayday bottle is 12 minutes and tone 2 minutes. My UFO tree, this one here, UFO tree and teepees. This one was 20 minutes and toned for 3 minutes. And my rabbit skull is 8 minutes and toned for 2 minutes. So I just keep my notes in a book, stuff that I know, my favorite images that I want to print over and over again. I write them down. I keep my note, but that's been on my shelf for almost 2001, 19 years, 19 years. That's been on my shelf over there. I've only used about half of it though. So I still have another 20 years. So, okay, let's see, Peter. Let's see what you do, buddy. Let's see yours. Yep. Talk to us.
No, it's just the very same. Everything I try. Like I'm messing about with acetic acid now, or sorry, acid for oratones. So I'm changing the acetic acid percentage to get cooler tones. So it's
perfect.
You need to document everything.
I tell people this all the time. I know it's hard. A lot of times we just don't take ourselves serious enough. And then one day you'll hit this perfect print, or you'll do something. Oh my God, I don't know how I did that. And then you can never regain it. So if you don't take notes, Tim works in carbon. Tim, jump on here, buddy. Tell us about how you do it and what you're doing. Tim does a lot of carbon printing, and that's where you really need to document it. I mean, carbon printing gets a little bit crazy.
What would you like me to tell you?
Talk about your process. Talk about how you have a negative. Do you check density? What's your dichromate percentages? What's your printing? Right. Yeah.
Right. So if I have a negative I want to print, and after you've used a densitometer a whole bunch of times, you really, you may disagree with me on this, Quinn, but you really don't even need to use it anymore.
I agree with you wholeheartedly.
It's a really great learning tool.
It is.
But once you've done a whole bunch of densitometer readings, you can look at any negative and say, okay, that's going to be 3 minutes, or no, I'm sorry, that's going to be 3% dichromate with maybe 10 seconds or 20 seconds. I did one yesterday, and I just looked at the negative, and I said, yeah, that's medium contrast, medium density. So I'm going to start with a middle of the road dichromate concentration. And I know that with a 3% dichromate concentration on the RioNet, it's probably about a 20-second exposure. So that's what you do. And then as you develop it, you look at it and you make adjustments accordingly.
Okay, so tell the guys, tell the people about this. When you talk about dichromate solutions, 2%, 3%, 5%, what are you talking? You mentioned a little bit, but tell us more about why that percentage is important. What are you controlling there? What are you doing?
Oh, okay. So dichromate it's not a silver product. It's a sensitizer. So you're going to put this over your paper to make it light sensitive. Okay. And your paper is made out of a gelatin sizing. So when you put the dichromate over the gelatin sizing, it becomes light sensitive, and then you expose it to UV light.
There you go.
So if you can have a 1% dichromate solution all the way up to, say, a 5% dichromate solution that you're using. So the 5% dichromate solution is going to be really, really sensitive to light, but you decrease the contrast of your image.
Isn't that kind of opposite of what people think, right? I mean, that's kind of a reverse.
Exactly.
Right? Yeah.
It's more sensitive, so your exposure time is going to be less, but it's a lot less contrasty.
Exactly.
So if you have a really high contrast image, you're going to want to use a high dichromate concentration in sensitizing your paper. Does that make sense?
Absolutely. Well said. Yeah.
Okay.
And here, what he's talking about there, he's talking about the tissue that he's sensitizing with the dichromate. Dichromate salts are exactly, you're right. They're sensitive to light when they're dried, right? So he takes his black jello or gelatin, he puts India ink or some color in, he puts a little bit of alcohol, he puts, thiamol, if he wants a preservative, whatever. And then he flows it on a piece of paper, lets it set up, it dries, and then he brushes dichromate on that tissue. When that tissue is dry, he puts his negative on it and he puts it in his RioNet or screen printer. And really, and here's the thing, tell me what you think about this, Tim. Don't you think it's important to have a screen printer, something you can manage for carbon prints rather than the sun?
Oh my goodness, yes.
Why is that?
Well, it's consistent.
And you can't see it printing out, right? You can't see what you get. This is a blind process.
Yes.
Yeah.
You don't know how well you did with your dichromate concentration choice and your exposure time choice. You don't know how well you did until you're in the hot water bath developing this stuff. And then you look at it and you go, oh my goodness, that's way too dark. Or
and that's a hell of a lot of work to get there, guys. Making your tissue, making your black jello, as I call it, pouring your tissues, drying them, sensitizing them, printing them out, and then you get in the hot water. Your developer is what he's talking about there, and you're way off. And that's why it's really important. Screen printer or something. These other pop processes, these are pigment processes he's talking about, oil and carbon. These pop processes, the salt and the collodion chloride and the things we've been talking about, you can visually inspect them. You can see, you can pull back your contact printer and see. You can't with this. You can't see it. The oil prints you can, and you have to judge the oil, but that's a whole different game. Yeah. But the black tissue, you have to know what you're doing. So that's a great explanation of that. And carbon printing, you don't see every day because it's difficult and it takes time. And I've seen Tim go from 0 to 1,000 and really dedicate himself to this process and using wet collodion negatives. And really, I'm impressed, Tim.
I think that the detail you get with a carbon print is unbelievable. It's just unbelievable the amount of detail you can get with a carbon print. I don't know if you all can.
Please. Yeah,
be able to see that.
Yes, let's see.
You can't. It doesn't really focus well.
Well, hold on. Let me see if I'm learning this. There you go.
I don't think you're gonna. But there's all these lines in this building that are the doorknob on the door, and the lines in the building are a thousandth of an inch thick. I mean, it's unbelievable the amount of detail you can get. you can get that with other forms of printing too, but I just love carbon printing.
Yes, I know you do. And I'm happy you do, because there's so few people working in these processes, let alone making wet collodion negatives. And then you up the ante by doing pigment prints. And I think people miss the boat. I mean, they're beautiful carbon prints from modern film and all that. They're beautiful. But once you dial in wet collodion with carbon, I'm with Tim. It's you can't beat it. That was the original. And these things have no silver in them. Like he said, they're non-silver images. They're archival forever. They'll never go away. And they're beautiful. I've seen that print and I've seen that negative, and I know exactly what in person. And it's I love gathering like this, but it's a shame we can't really get the but we get the idea. So I appreciate you sharing that. So let me go back to, thank you, Tim. That was awesome. Let me go back to my notes here. My notes say, and then I'll say, so Tim asked, how do you do that? And how do you dispose? Okay, here's your second question, Tim. Out in the field, how do you dispose of waste chemicals? I've been dumping them in the weeds near my work site. Is this okay to do? So here's the answer to that. Well, let's break that down first. When you're in the field, what do you have? You have collodion to pour your plates. You have silver bath to sensitize your plates. You have developer to develop your plates. You have stop bath water to stop your plates. And you have wash water to wash your plate or fix your plate. You have fixer to fix your plate, and then wash water to wash your plate. Those are the things we have, right? So let's talk about the disposal of each one of these. You've prepped all your plates at home. So if you're doing glass, all the cleaner's done. There's no rags. There's no nothing there. If you're doing tin types or aluminum types, you're just peeling and pouring them. Have your garbage sack. You throw your plastic in there, right? You have your collodion and your drain bottle. There's no waste in collodion there. You pour it and drain it. So there's no waste on collodion. You have your silver bath. You sensitize that. God knows no silver bath waste, right? We don't want to throw out that precious metal. So there's no waste on your silver bath. Now we get to your developer. So let's say you're doing whole plate and you're doing 30 mils a shot of developer. We just talked today. That's why this is such a good segue into this. What's in your developer? Your carrier is your distilled water. Your reducer is your iron sulfate, which is just like a high, heavy fertilizer, basically nitrogen-rich fertilizer. Your glacial acetic acid or strong vinegar, and a little bit of alcohol, if you have any alcohol in there. Just a little bit, not too much. You pour that on the plate, you drain it off, and you have your rinse water. So by the time you dilute that down in your pan, what you're talking about there is either a weed killer or a really good fertilizer, or maybe both, depending on how much acid you have in there. There is nothing that I see, unless you're in a very highly controlled area, that would prevent you from pouring that out in the field, in a dirt pile, in a mound, something like that. If you're really, really concerned with it, look at each MSDS, each one of those compounds, and look at what's in it. Man, we flush more down our kitchen sink than we'd ever touch here, right? So I'm okay with that. If you want to pour that in a 5-gallon jug and top it off and take it home with you, do that. But I don't know what are you going to do with it at home? You let it evaporate into the air, let it evaporate, fill it back up, pour it down your drain. You're basically doing the same thing. So I don't see anything in there that's going to do, especially diluted down with your wash water and everything else. I don't see anything in there that's going to harm anything. So you've stopped it. Now you put it in your fix that plate out, let it drip, wash it off in your pan, another liter of water in your wash pans or whatever. Your fix is reusable. You pour that back in your jug, seal that up, put it in your cooler. So your wash water's there. By the time you wash a few plates through and you switch that out, you're going to have a tiny, tiny bit of AgCN. There's nothing there that's going to hurt anything again. You could put it in a jug again and take it home if you want, but you're going to be packing a lot of water around. So, and then if you varnish in the field, you have no waste in the varnish. I probably wouldn't recommend varnishing in the field just because wind and problems and all kinds of stuff. So you're probably going to wait till you get home to do that. You might even put your wash portion in a sealed bucket or a sealed We talked about those waterproof deals, or you can carry your plates around in. You might even wait till you get home then. So really, there's nothing, and you guys may disagree with this, and you're welcome to, but there's really nothing that's going to hurt the general environment with some developer wash water and putting that out. And, you know, I mean, I don't know that I'd dump it in your drinking water, of course not, but how the earth takes a lot more. Just think about the acid rain and all the crap. Think about the crap that comes down by these. I mean, none of it's good, but you're not adding to that problem in that context. Not in these volumes. I just don't see that. So that's great questions. And if anybody wants to chime in, they can on that. So let's go back to this. I asked this question last time. Let's bop over to these aristotypes. Remember when we talked about the Greek word aristos and tupos? Anybody speak Greek? Do you know what that means? What is it when we talk about collodion aristotype or gelatin aristotype? Do you know what we're talking? What does that mean, aristotype? People have been asking me that lately, and I'm not sure why. Anybody speak Greek? Milas Ellinika? Anybody speak Greek? No. Yeah, somebody's getting in here. No? Okay. Aristos means best, and tupos is type. So best type. Why is it called best type? Because really, when we talk about archivability, we talk about a collodion aristotype, collodion best type. We're talking about prints that are, you know, you got a layer of plastic, basically your collodion, and you got silver. And if they're toned, especially gold tone, you really up the ante on archivability. These have been found that have been made, you know, 100 years ago, and they look like they were made yesterday. The problem with albumin, sometimes salt, some of these others that kind of embed in, I mean, albumin kind of rides up on egg whites, but once you get embedding in with gelatin on salt and those kinds of things, you get deeper in the paper, the more problems you're going to have of washing that material out. And that's the problem you don't have with aristotypes, collodion aristotypes or gelatin aristotypes. I want to show you, let me show you that I've been experimenting. Let me show you this gelatin aristotype I've been playing with. Trying it on different papers. Now that we're all trapped inside and by our lonesome, I've been trying different. Here's a couple more. Here's probably a good representation. That's a collodion chloride print. You can see it's quite glossy, quite stable. That's that final type that I got in there. You probably saw this online. A menorah and that beer bottle. Those are collodion aristotypes. Now, this is, what kind of paper was this? This was Hahnemühle. And this is a collodion gelatin that I brushed on. I was trying this brushing method, but you see these streaks on this. Great negative for it, though. And then I started on this Arches. What is this paper? This is an Arches paper. But this started, look at the gelatin melting down here. This is really cool. I'm going to play with this stuff. This has potential for me. It embeds and it makes it a little tougher. That's what gave me the thought about this. It makes it a little tougher for traditional, like salt. That's what's used for salt prints. I've been trying this. You can see the surface difference on these. One's matte. This is matte. That's like a salt paper, and this is like more like I think this is actually a burrito paper. It might be a burrito paper. I have to look at my notes, but. Gelatin is another great way to gelatin aristotypes. So you take gelatin, silver nitrate, distilled water, brush it on, hot gelatin, brush it on a piece of paper. I've been playing with these. I've thrown a few of them away. Is there anything here? No, not really. But I've been playing, since we're all kind of trapped inside now, I've been playing around with some printing. But I'm going to continue to explore these. And everything that I've done archival-wise, I always like to run a print. I always like to do a few things, try out a different type of varnish. try a different type of wash times and put them in windows and see what happens. You need to experiment on your own how you want to make your prints. I mean, traditionally, the literature is good and will probably get you in a pretty safe place, but there's always those weird anomalies where papers are being switched around. Just in the last couple of years, people making tin types, you know, the aluminum plates, alumitypes, tin types, whatever you want to call them. They switched up their formula in that and really screwed some people up. Fogging that will not wipe off, veiling that will not wipe off, chemical changes in the materials. It's really difficult unless you're using glass or you're using a tried and true paper to print out on. Those are your best options for staying consistent. I've seen the aluminum change quite a bit over the years. 2 or 3 years ago or 4 years ago, I don't know how long this has been, they changed the percentage in collodion. So it used to be everything was it says total is say 4 to 8% of nitrocellulose in collodion. A couple, 3 years ago, for whatever reason, they dropped it way down, probably to save money, right? And all of a sudden, you couldn't make collodion chloride emulsion anymore. And I was like, God, what is wrong here? Is my silver? I wish I still had some prints to show you what happens. It's basically just, it's a mess. It kind of looks like that. Kind of looks like that. But it's not. That's a an old gelatin paper I was messing with. But changes in the products mess everything up for us. So it's keep notes on that, because one day you're working with this one compound that you've always got from this one place, and all of a sudden you can't make images anymore, and you're like, what's going on here? So a lot of times people change things up, manufacturers switch things, and they don't, you know, we use things from other areas in the world making other types of products that they don't even think about us. So, you know, changing a surface on a tin type or an aluminum type isn't going to change anything. Jan says, how about varnish with Sandorak to get deep in the paper like the yellow tones? The problem with varnishing a non-burita paper, you know, we've talked about this before. The burita paper like this has a layer of barium, so you can pour collodion, the solvents won't go through. Well, varnish has alcohol, which is a big solvent, right? Berger Cott 320. Yeah, the problem with that is when you pour alcohol on that paper, you'll go right through it. You'll go. I mean, you could try it. You could try and see. I'm not sure. You're talking about changing colors of the print. Is that what you're talking about? Yeah. Oh, you tried it. Well, get on here, Jan. Tell us about it. Tell us about it.
Yes, hello.
Hello.
I used today. Yes, I try it for 8-10 contact prints, and sometimes I like to have a more yellow tones. I'm not sorry for not speaking good English, but
no, you're great, Jan. Your English is great.
Yes, and it's not good light here, but I got much more sharp. I got deeper. I feel it's got deeper and sharper pitch.
Okay, tell us what you did there. You use gum Sandorak varnish like you varnish with tin types and glass plates. Okay. Yes. And this paper is Berger COT 320.
Yes. And sometimes I think if I take beeswax and oil, lavender oil, and I have it behind glass, and if it's hot day and or sun staying on the picture, the glass got foggy.
Yes, that's true. I've heard this before. That's true. That's true.
And I think this is more like lac, what you call it, hard painting. It's like
lacquer.
Yes, yes.
Very interesting. There you go, guys. There's another great tip on experimenting for archivability and presentation.
Also today, you see it's a little bright here because of the sun, and I think also I have it for. Normally, I have contact print 8 minutes, between 8-10 minutes. About I just starting with the negatives for 4 weeks ago,
Excellent.
and I take some contact prints earlier also, but no, I feel I'm start be good. But this today was very bright, too white. I don't like because the paper was too like digital white.
Yeah.
I want this little yellow finish,
Yes.
and that's why I get back from the Sandarak.
Excellent. So what he's saying is he likes the warmer tones, and he's getting that warmer tone by using Sandarak. I have to admit that's the first, and that's a salt print. Yes, Jan? Salt?
Yes, this is salt print.
Yes.
I shoot it for 2 days ago. It's maybe you see it's some rain in the window.
Yes.
I'm feeling in the morning.
Beautiful.
It was
Beautiful.
the mood in the morning.
So if you don't want to use wax, guys, try the gum Sandarak. That's excellent. Thanks for sharing that. That's great. That's the first I've seen of a gum Sandarak print.
Yes, if you just think you print everything, people have children here sometimes taking a picture. I just can clean it easily after.
Yeah. Yeah.
Not go so deep.
Yeah.
More like wax. You got if you have dirty black fingers on it, you get spots on the
Excellent.
picture.
Excellent. And this is why it's really important. Thank you for sharing that, Jan. This is why it's really important to have the plasticizer, right, in your gum Sandarak. This is what will keep that tree sap movable especially on a print, right? I mean, you want that anyway, but that's interesting. Anybody else ever varnish their prints with gum Sandarak? That's very interesting. I've never done that. I've never done that. I will try that, Jan. I will try that. That's a very interesting point. I always felt like the alcohol would eat right through that paper. No problems with burrito paper. I wouldn't have any problem. But like, I'll try some gum Sandarak on this.
Hello. And
Yeah.
I think about the gum Sandarak. Some with spirits, it's going deep in the paper.
Yes.
Conserve everything silver and everything inside the paper.
Yes.
If you have gelatin and everything, you you glue it together. You glue everything together, so you don't have an interaction of chemicals in the papers. I think
That's good. I can see where you're going with that. That would make sense. I bet you in the 19th century they probably varnished prints with gum Sandarak. I could probably almost guarantee it they did. So that's excellent. Good points. I love it. I love it, guys. That's wonderful. Well, I've gone through my list. Anybody else have anything? We can. It's 11:51. That's about 2 hours. I'm going to call that good. I'm going to be in here next week. We'll cook up something really good for next Saturday. I'm going to get my phone hooked up and we can go into the dark room, so we can leave here and go in the dark room and maybe do a couple of things. If you guys have something you want to talk about or you want to share, you want to come on and share, man, I'm game for that. I am totally game for that. I love Zoom as well too, man. That Zoom is this, no problems. I struggled with YouTube. I had that OBS software. I'm super happy with this. I'll continue. I've got meetings every week now through May something. So everybody's on lockdown. Yes.
I would love to see other people's work and good things, bad things, even things they're struggling with. You want to show us some solvent streaks.
There you go.
Show us that and show us how you got rid of them and what you do about that. And,
there you go.
I would love to hear from other people about some of their work and what they're doing.
Let's do that. And you know what? I'll up the ante on that, and I'll go one more. And let's have a technical portion, a sharing portion, and then let's do some conceptual stuff. Let's all go around and talk about why we use this process, or what we'd like to do with this process, or maybe a project we're working on, and show some examples of that, or get some feedback on some ideas of conceptually, maybe shift from the technical to the conceptual. We can move back and forth. And then definitely share the technical stuff, your successes, your failures. Your failures are as or more important as your successes for sure. Show some good work, some bad work, whatever, like Tim says, and let's share. I mean, I think the world's going to be locked down for a little while. I think we're all going to be locked in for a little while. So this is great to be able to chat with everybody. And oh, good, Linda's in here. She's going to test her new chemicals tomorrow. I hope it goes well. Hey, Linda, come back next week and let us know. Good, Peter. I want to see that. Yeah. And Pat, jump in here. Yeah. Any questions, anything you want to do, I'm open. I'm game. I love it.
This has been great. I think Zoom's a great idea.
I do too. I think this has worked out. I have no technical problem. I thought it was me last week. And then, you know, who was it? Jan, I think, maybe wrote me and said, hey, you might be having problems because everybody's at home now or everybody's online. And I got looking into that. I think that's a plausible theory. I think they haven't got the bandwidth and they haven't got, you know, anything going. And I've recorded all of this. So if we feel like putting it up on YouTube, we will. If, you know, if we want to share it with the world, we can. I think I will. So ladies and gentlemen, thank you so much. And join me next week, same place, same time, same bat channel, all that good stuff. Bring your work. Bring your ideas. We're interactive now. It's not just me up here rambling. I'm happy to answer questions if I can, though. So thank you so much, ladies and gentlemen. Be safe. Be strong. We'll get through this together. Make the world a better place. Thank you so much, guys. Ciao.